Okay, this video is going to focus just on price elasticity of demand. What is price elasticity of demand? Well, in the last video, we said that price elasticity of demand looks at how sensitive consumers are to changes in the price. So basically, let's say that we have a 10% change in price. Okay, so the change in price of good X is equal to 10%. So we want to figure out what's going to happen to the change in Y. So basically we have three options, or the change in our buying habits of good X. So over here, we're going to look at possible percent changes in quantity demanded for good X. Okay, so in one situation, we can have that there's a 10% change. Okay, so that means the change in price resulted in the exact same change in quantity demanded. Okay, so over here we have change in price resulted in the exact same change in quantity demanded. We call this unit elastic. Unit elastic means that however much the price goes up by, the quantity demanded is going to fall by the same amount. Okay, so let's say that there's an increase in quantity demand price by 10%. We're going to see that there's a decrease in price by 10%. And this isn't surprising that it's a negative relationship, because we know that the demand curve being downward sloping, that there's a negative relationship between the price of good X and the quantity demanded of good X. Okay. So if there's a 10% decrease, we could have a greater than 10% if there's a 10% increase, we could have an 11% decrease in quantity demanded, or we could have greater than 11% decrease. So we could have 12%, a 15%, a 20%. All of these things where we have greater than unit elasticity means that the amount that quantity demanded is falling by is more than the change in price. So over here we see that consumers are very, very sensitive. Could even be greater than 20%. We could go all the way down to 100% change in quantity demanded. So this means essentially that people aren't buying this good at all anymore. Okay, so this extreme case where it's 100% decrease in quantity demanded, this is what we call perfectly elastic. Okay, that means in this special circumstance where if there's an increase in price, we go to a complete complete decrease in quantity demanded of 100%. This idea of perfectly elastic, this means that quantity demanded is now equal to zero. Okay, so perfectly elastic good is a good or service where the demand curve actually, if this is the price of good X and this is the quantity demanded of good X, this is what the demand curve looks like. Okay, if the price was $10 and they increased it to $10 or $11, there's absolutely zero demand for it. Okay, so the quantity demanded right here would be zero. Okay, so that's a perfectly elastic. These other ones where it's greater than 10%, this is in what we call the elastic range. Okay, so consumers are very sensitive in this elastic range. Okay? And then the opposite is up here, where if there's an increase in price by 10%, there's a decrease in quantity demanded by less than 10%. So let's say 9%, or anything less than that. We could even say all the way down to a 0% change. Okay, a 0% change is again like this perfect idea, and this would go all the way down to, if there's a 0% change, it goes all the way down to when we see the idea of perfectly inelastic. Perfectly inelastic. That means that consumers are so insensitive to a change in price that it doesn't matter that the price has increased by 50%, they're still buying the same amount of good or service. And then anything from, this 9% to less anything greater than 0. This is what we call the inelastic range. So another way that we can look at this is we can look at this as kind of a number line of sorts. So let me get a new page going, and we can see that if we have a number line, kind of an ongoing continuum of elasticity, we can have our two extreme cases: the case of perfectly elastic and the case of perfectly inelastic, and then right here in the middle where we have the elasticity of demand. So this is the price elasticity of demand, but we're just going to call it elasticity of demand. Well, the price elasticity of demand is exactly equal to 1.0. Now, what does this coefficient mean? This means for every 1% increase in price, it's going to lead to a decrease of 1% in quantity demanded. So if we were to look at the formula for price elasticity of demand, we would look at the percent change in quantity demanded divided by the percent change in price. Okay, so this is going to give us our elasticity of demand formula. So here, the elasticity of demand of 1.0 means that we have what we call unit elastic. Okay. If hamburgers go up by 10%, I'm going to buy 10% less hamburgers. If homes go up by 15%, I'm going to buy 15% less homes. Okay. Now over here, we have what we're going to call the elastic range. Now in the elastic range, these numbers get continuously larger. Okay, so we can kind of think of this as a number line. Technically, all of these numbers are negative. Okay, all of these numbers are negative because we know that the change in price, as price goes up, it has a negative effect on quantity demanded. So this is technically a negative one. However, economists kind of drop the idea of negative because we know that as numbers become larger, if they're negative, they're actually becoming smaller in the real world. So that gets very confusing. So we just look at the absolute values of this. Okay, so the absolute value in the elastic range is when it's greater than 1. So maybe we have something like the elasticity of demand equal to 2, which is a very elastic good or service. And then we have all the way down here at the end, it's almost like a hypothetical situation if we had elasticity of demand equal to infinity. Okay, the elasticity of demand equal to infinity, saying that it's so elastic, consumers are so sensitive to change in price for this particular good that we're going to call it perfectly elastic, that even if the price goes up by just a tiny bit, consumers are going to quit buying this good or service completely. So this is what we call perfect elasticity. Okay, now your book gives the example of looking at value meals. If a value meal, if you're at the airport and there are all these different value meals where the hamburger is exactly 99 cents and you're kind of indifferent between the different types of hamburgers, you're not going to buy one if it's $1.05, if all the other ones are 99 cents and assuming there are no lines for any of the hamburger joints, then you're going to not buy one that's over 99 cents. Everybody's idea of elasticity is completely individual. If you happen to prefer one type of hamburger over another, then you're not going to have that same view. You're going to say, no, even if that type of hamburger, maybe In-N-Out, even if In-N-Out hamburgers increase by 10%, I'm not really going to change my buying habits. What that means is that you are over here on this side of the equation, and you believe that In-N-Out hamburgers are extremely inelastic. So this is what we call the inelastic range. Okay, now if you happen to think In-N-Out burgers are the greatest thing ever, And even if the price doubled, you'd be still buying the same amount. That still puts you in the inelastic range. There are very few things that are all the way down here where we see that the elasticity of demand is equal to 0. Okay. When you're in this in-between range, maybe you see that the elasticity of demand is equal to 0.5 or 0.8 or 0.2. And what that means is that you're relatively insensitive to changes in price. You might buy a little bit less, but you're not going to buy significantly less, okay? Over here at this far extreme, this idea of perfect inelasticity if a good or service is perfectly inelastic, even if the change in price increases very significantly, your change in quantity demanded is exactly 0. Okay? The change in quantity demanded is 0. It doesn't go to 0, it stays the exact same. So basically, if we were looking at a percent change over in that far left-hand side over here where we have the perfectly inelastic, if we were to say there was a 10% change in quantity demanded and divide that through by 0, we get an error. Okay, so whenever we're trying to divide anything by 0, we're gonna get that it's not a possible number. So that means that for the slope over here, the slope of this curve is going to look like this. This is the demand. So this is the price of good X, this is the quantity of good X, and we'll see that regardless of what the price is, if the price is $10, if the price is $20, consumers are buying the exact same amount. Okay? We usually see this, well, we don't see it very often, but the closest example of this is that we have are something like medical bills. You pay you don't necessarily pay them, but you get your medical treatment regardless of the price. So if you are diabetic and the price of your insulin increases by 20%, you're still buying the exact same amount of goods and services. Is there an upward bound to this? If insulin becomes, a few $1,000s per shot, are people going to look for other alternatives? Absolutely. So we try to keep this in within the realm of possibilities. But over here on this perfectly elastic side, we see that the demand curve if it goes up at all, if there's an increase in price, quantity demanded goes to 0. Here, there's no change. So here, there's a 0% change in quantity demanded, which is very, very different than over here. Quantity demanded is equal to 0. Okay? And then in the middle, when we have something that is unit elastic, the correct, or the closest that I can draw, let's see how close I can get with this, for a unit elastic good or service is, if we're looking at the price and quantity, it's going to be a curve something like this. Okay, and in unit elasticity, I guess one of the easiest place to look at this is if we have a certain budget that we allocate to doing something, like maybe going to the movies. If we're going to go to the movies, assuming that the price of a movie could change only by 10%, then your quantity demanded would change by 10%. If you have $100 allocated a month to doing something, if it decreases or if it increases in price by 10%, you would have to decrease your quantity demanded by 10% because you're restricted by your budget. Okay, so this is kind of a kind of an ongoing continuum between these. Obviously, if we were looking at things in the elastic range, this overall elastic range is where the demand curve is going to be relatively flat. And in the inelastic range, this is the area where the demand curve is going to be relatively steep. Okay, so again, price, quantity, price, and quantity. So there are a couple different things that affect our price elasticity of demand, and one of the biggest ones is the number of close substitutes. Okay, so if we're looking over here at this perfectly elastic area of the continuum, for me, the closest idea of perfectly elastic that I can come up with is computer paper. I go into Office Depot or Office Max to pick up my computer paper, and all of the computer paper looks relatively close. It's all roughly the same price. If one is higher than the rest, I'm not going to choose that one. Okay, so it's something that there are a lot of close substitutes for. Over in this perfectly elastic range, there are 0 substitutes. Okay, there aren't any substitutes for, medical treatment if you need it. There aren't any substitutes for insulin shots if you need them. So the more substitutes we have, the more elastic it's going to make a good or service. So the more substitutes we have, we're going to see that we're going to be in this range, where the fewer substitutes we have, it's obviously going to put us over here in this range. And at the end, there are exactly 0 substitutes, and over here there are an infinite number of substitutes. So if we're thinking of substitutes, we see that these numbers are repeated again. Elasticity of demand over here is infinite when there are an infinite number of substitutes, and elasticity of demand is 0 over here when there are 0 substitutes. Okay, so this is a good start for elasticity of demand. Again, make sure that you're doing the mathematical applications in the book to see how this is used and practiced every day, kind of in the real world.